So, what does your local Sunday football sports bar actually have in common with, say, a NASA mission control center? I mean, the answer is hiding right behind the drywall.
Yeah, and it involves this uh, massive labyrinth of cabling and hardware that most people, they never even think about.
Right. So, welcome to this deep dive. Today, we're looking at a huge product catalog from HDTVSupply. They're a global AV distributor, like 25 years in the game.
Which is a really long time for AV tech.
Oh, absolutely. And we are using a very specific setup as our entry point today. It's the Epiphan EPI-ESP1911 production plus Pearl2 bundle.
A mouthful.
It really is. And it comes with 3 EC20 PTZ cameras. You know, those pan, tilt, zoom cameras you can operate remotely. But getting that pristine 4K video is really just step one. Our mission for you today is to uncover the invisible infrastructure that actually routes all that visual data around you.
Because, well, getting a 4K image into a camera lens is relatively easy, right? The real physics problem is getting it out to a display without degrading the signal.
Exactly. I mean, capturing the footage creates this immediate issue of data weight. Like,
Yeah.
where does all that heavy, uncompressed 4K video actually go?
Right.
And the catalog reveals just this ocean of industrial scale distribution equipment. We're talking over 2,000 different HDMI modular matrix switchers and setups using standard CD6 Ethernet cables to push 4K 60 hertz video up to 450 feet.
Yeah, 450 feet is a massive distance for that kind of data.
Wait, really? So how is a standard network cable handling that kind of visual payload over that distance?
What comes down to transmission standards, like HD-base-T and AV over IP. They don't just shove raw video down a copper wire.
Okay.
The hardware actually encodes that dense video signal into standard data packets. It compresses it visually without losing the core quality, and then it shoots it across a standard IT network infrastructure.
Okay, so when we look at these sprawling 160 by 160 matrix switchers, meaning they route 160 inputs to 160 outputs simultaneously, I've always pictured it like a highly caffeinated traffic cop waving pixels through an intersection.
I mean, that's a fun visual, but it's actually not how the mechanics work at all.
Oh, really?
Yeah, because a traffic cop has to stop cars to let other cars pass, right? A matrix switcher is more like an automated, high-speed postal sorting facility.
Okay, tracking with you.
It can take one visual data package, instantly duplicate it 160 times right at the hardware level, and deliver it to 160 different destinations on the exact same millisecond perfect schedule.
Wow.
Yeah, that strict clock synchronization is how they route everything without dropping a single frame.
I do have to push back on the sheer scale of this, though. Like, most of us just have one screen, maybe a streaming box in our living room. Who's actually sitting there watching 160 TVs at once?
It's a fair question.
Why do they need centralized routing for all of that?
Well, think less about one person watching 160 screens and more about managing viewer bandwidth. In a complex control room, a multi-viewer system prevents information overload. Because the hardware manages the clock sync so perfectly, an operator can instantly push critical data to a specific wall monitor exactly when it's needed.
With zero lag.
Exactly, not even a microsecond.
And that demand for zero lag brings us right back to our original question. When you look at who actually buys this labyrinthine gear, you see two completely different worlds colliding in this catalog.
Oh, for sure.
On one side, you've got commercial sports bars hooking up complex 10 by 10 video walls.
Right, to create this highly chaotic entertainment environment.
Yeah, but then the very same supplier is selling through incredibly strict government channels. The catalog specifically lists the NASA CEL-EP program.
Which is the government's rigorous IT procurement channel.
Exactly. Along with federal GSA schedules and TAA-approved trade-compliant products. So,
Is a modern sports bar basically running a mini NASA mission control?
pretty much, yeah.
Why are they using the exact same hardware tier as a space agency tracking satellite telemetry? Because the underlying engineering requirements are identical.
Really?
Yeah, I mean, to sync a sprawling 100-screen video wall for a Sunday football crowd, you can't have one screen lagging a fraction of a second behind the others.
Right. It ruins the illusion.
It completely ruins it, and it causes the image to tear. So preventing that requires the exact same mission-critical reliability, hardware-level encoding, and pixel-perfect routing that aerospace operations demand.
That is just wild to think about.
Physics just doesn't care if it's a football game or a rocket launch, you know?
Yeah.
Perfectly syncing data packets across that many displays requires uncompromising, zero-latency processing.
So what does this actually mean for you listening? Next time you're sitting in a venue completely surrounded by perfectly synchronized screens, Don't just look at the game.
Yeah, take a second to appreciate the industrial-scale processing working tirelessly behind the walls. It definitely changes how you look at the ceiling tiles in public spaces.
Absolutely. And I'll leave you with this to mull over. If the commercial off-the-shelf equipment sitting in your local sports bar can effortlessly control 160 synchronized screens in pristine 4K resolution, what on earth does the bleeding-edge visual infrastructure of a fully classified proprietary network look like?
A very good question.
Next time you see a perfectly synced display, just imagine what's actually hiding in the walls.